Hi everyone, so today we're going to talk about the vertex or the intercept form for quadratic functions, and we're going to start out with your warm-up exercises. So go ahead and take a second, and you are going to find the product of the following functions. So we're going to graph the vertex form y equals a times x minus h squared plus k. This is a new formula. And what you need to know is that the graph of this particular function is a parabola of y equals a x squared, and it's translated. So what does that mean? It's shifted throughout the graph. So this graph is actually going to be translated horizontally in h units and vertically in k units. So that means that my basic parabola, we're going to be able to shift it h number of units or k number of units. There are also some different characteristics for this particular function. The vertex is just at the coordinate point h, comma k. So you no longer have to solve for the vertex, which is really nice and convenient. Ax is your axis of symmetry. I'm sorry, axis of symmetry is x equals h. That didn't make sense to me. X equals h is your axis of symmetry, and the graph is going to open up if a is greater than 0 or down if a is less than 0. That's the same as our standard form, right? So those are just your key concepts that you're going to throw right in your note-taking box on your worksheet. This particular form of a quadratic function I think is a little simpler to work with, but we'll see. We'll do a couple examples for you to get the hang of it. Example 1 says to graph y equals -1/4 x plus 2 squared plus 5. And we know some new things about these expressions, right? Instead of having a, b, and c, now we have a, h, and k. And we're going to use them in a new way. So a is our 1/4, -1/4. H is -2. And k is 5. Now, you might be looking at this and going, what do you mean h is -2? This is a +2. But if we take a look back at our original form, you can see that the function here is y equals a times x minus h squared plus k. So when I'm looking at this example, because I see the plus sign here, that tells me that that 2 is actually negative because my original function should be minus, but if it's minus a -2, it turns into a plus, and that's how I know it's negative. So that's kind of a tricky piece that you're going to want to pay attention to as we're moving forward. So I found my a, h, and k. I know that my graph opens downwards, so it's going to have a maximum because a is less than 0. So now let's just find some important information. My vertex is just going to be h, comma, k, which is -2 and 5. So I go to -2, 5, and I plot that vertex. Now I have a graph for you to do this on, but obviously my graphs are already finished, so just follow along like you can. My axis of symmetry is at h, so that's equal to -2. So you can see this red line that I'm dotting over, that's my axis of symmetry. And now I can evaluate for more coordinates and reflect over my axis of symmetry just like I do with standard form. So this one's going to be a little trickier because we do have that square. It's a little more of a complex formula, but we can work with it. So let's say, for example, my first x value is going to be 0. I can plug in y equals negative 1/4 times 0 plus 2 squared plus 5. 0 plus 2 is 2, obviously. 2 squared is 4. Negative 1/4 times 4 is negative 1 plus 5 would equal 4. So at 0, my y value is equal to 4. So if I go to my 0 axis and I go up 4, I can plot another coordinate. I can also do this with maybe x equals 2. Plug in that value. So 2 plus 2 is 4. Squared is 16. Negative 1/4 times 16 is negative 4. Plus 5 would equal 1. So at positive 2 x value, my y value would be 1. Now I reflect over the axis of symmetry just like I used to with my standard form. So I go 1, 2 spaces to my axis of symmetry, 1, 2 spaces out to my new coordinate, 1, 2, 3, 4 spaces to my axis of symmetry. So I repeat out to my new coordinate. And I can go ahead, connect those 5 coordinate points, and come up with a really nice parabola. So hopefully you can see that we're doing a very similar process. We're finding the vertex, we're finding the axis of symmetry, and then we're substituting in x values to find our y values in our graphs so that we can go ahead and graph that equation. Example 2 is a problem about engineering. It says the Tacoma Narrows Bridge in Washington has 2 towers that each are 307 feet above the roadway and are connected by suspension cables as shown. Each cable can be modeled by the function 1/7,000 times x minus 1400 quantity squared plus 27. Where x and y are measured in feet, what is the distance d between the 2 towers? So this problem is actually not that complicated. I know that this distance thing might seem strange, but what point would give us some key information here? It's actually the vertex. So my vertex here is 1400, 27, right? Because it's just h and k. And when I think about that vertex, the vertex is the center point of the suspension bridge, right? So it's actually right here in the middle. And if I'm 1,400 feet away from the edge of the graph, or where my y-axis is, right? Assuming that this function starts at the y-axis and that one of my coordinate points is actually 0, 307, then the distance between that point and my vertex is 1,400 feet. That's halfway. So to get the full distance from one point, 307 feet off the ground, to the second point, 307 feet off the ground, I need to go double the way, so I need to go a distance of 2,800 feet. So it seems like a complicated problem, but when you read it and you think about the information that you're given, it's actually not, right? So to find the midpoint of that bridge is pretty straightforward because I know where the vertex is going to be. And because that's also my axis of symmetry, I can just reflect over that axis and double the distance that I have to find out what's the distance of the total bridge. The next set of key concepts is to graph the intercept form. This is again another new form of a quadratic function. The x-intercepts in this particular form are P and Q, not P plus Q, but P and Q, which is useful information. The axis of symmetry is halfway between point P, 0 and Q, 0. So my axis of symmetry is halfway between P0 and Q0. And it also has an equation. My axis of symmetry has an equation of x equals P plus Q over 2. And that makes sense, right? Because if I was going to go halfway between the two, that would be my equation for axis of symmetry. Now I know there's a lot of different equations and a lot of different information in this particular video. It's just really important to realize that we're using the same process. We're continuing to think about how are you going to graph a function in a variety of different forms. So you don't need to memorize P and Q and all this kind of stuff. That information would be in your notes for you to use for class. You will need to memorize it by the time we have an assessment, but that won't be for a little while. So, continuing, let's graph y equals 2 times the quantity x plus 3 times the quantity x minus 1. And this is pretty straightforward. When I'm looking at this, I just want to identify p as 3 and q as -1. So I know that my axis of symmetry is going to be halfway between p and q, right? So in this particular case, as long as I plot that point, so halfway between P and -Q, 3 plus -1 is 2 over 2 equals 1. So at a positive 1 value, I'm sorry, that should be -1. At a -1 value on my graph, that's where I'm going to see my axis of symmetry. So I can figure out what my y coordinate is going to be. Y equals 2, -1 plus 3, -1 minus 1. So remember, you're going to use FOIL. You can distribute first or you can distribute second, it doesn't matter. So 2 times -1 is -2 plus 2 times 3 is 6. Now use FOIL. First is 2, outer is 2, inner is -6, and last is -6. So 2 and 2 is 4, -6 and -6 is -12, which gives me a coordinate of -8. So at -1, my vertex is going to be at -8. There we go. So now I have a vertex point and I have an axis of symmetry, and I can continue to plot coordinates in order to figure this out. So maybe when x is 1, what would my y be? Well, when x is +1, I'm going to get 2 plus 6, and then 1 minus 1. And again, continue to do first, outer, inner, and last. 2 minus 2, 6 minus 6. So that's going to be a 0. I reflect over my axis of symmetry, connect my dots, and I have my quadratic. So again, figuring out where the vertex is going to be, substituting in values, and working from there. Your daily homework quiz is to graph each function on the same coordinate plane, A and B.